Ladies and gentlemen, good afternoon. Thank you so much for being with us today, and welcome to the event called Energy Intensive Industries, Innovative Technologies Towards Climate Neutrality. My name is Kathleen Engelbosch. I am the head of department responsible for digital industry and space at HDEA. And HDEA is the executive agency for health and digital of the European Commission that is organizing this event today as part of the EU Pavilion. In this session, we will discuss and present the EU policy initiatives in the field of energy-intensive industries, and we will hear from 3 EU-funded projects that are demonstrating how new technologies can be used to decarbonize this particular sector of the EU industry, namely the energy-intensive industries. And these are, for example, the industries that produce iron and steel, cement, lime, chemicals. Today, we can say that these energy-intensive industries, they make up more than half of the energy consumption of the EU industry. And although the European process industries have substantially reduced their emissions in the last decades, the figures of 2019 demonstrate to us that these industries still represent about 17% of the EU greenhouse gas emissions. So for these industries, the energy-intensive industries, climate neutrality is a real challenge. It requires a fundamental transformation of the industrial processes while they need to remain competitive at the same time. But we believe we can address it when we have the right policies, the right instruments, and the deployment of new technologies. We have today 4 distinguished guests with us, experts in the field. Next slide, please. So first of all, we have Jürgen Tiedje. Jürgen is the head of unit for industrial transformation in the European Commission, and more in particularly in the DG Research and Innovation. And he will outline us how the EU is strategically representing itself towards climate neutrality for the EU industry. And he will also explain to us the role of research and innovation in this process. Then we will hear from 3 EU-funded projects that developed new technologies to decarbonize these industries. We first of all have Angela Nunes. Angela is the head of innovation, product and process development at CECIL, which is a Portuguese group producing and commercializing cement and concrete. And Angela will speak to us about the retrofit project, which is seeking to retrofit core equipment in process industries in order to gain in efficiency and resources. Then we have Lisbeth Horkmans with us. Lisbeth is a senior researcher at VITO, and VITO is the Flemish Institute for Technological Research. Lisbeth will explain to us and talk to us about the Carbon for Minerals project. She will explain how CO2 from flue gases can be transformed into added value construction products. Finally, last but not least, we have Javier Diaz Maroto. Javier is the Breakthrough Innovation Manager at the Solvay company, based in Brussels, and he will enlighten us about the project Power to Hype that seeks a pioneering route for electrochemical synthesis of hydrogen peroxide. At the end, there will be also a Q&A sessions, and you can already see on the screen the details to interact with us using Slido. So do not hesitate to submit your questions during the session. So I think it's clear we all understand we have a common challenge, and that is to lower the CO2 emissions while keeping our industry competitive. If we want to meet the target to become the first climate neutral continent by 2050, then we need to take action. And we need to take fastly action. I'm very proud to say that HDEA is supporting this goal. I just take the opportunity to explain a word about HDEA. So HDEA is the European Health and Digital Executive Agency, one of the 6 executive agencies of the European Commission, with a precise mandate to implement and manage European programs delegated to the Commission in 5 areas. You see the areas on the screen. It's health, food, digital industry, and space. HDEA became operational in April 21, in the middle of the pandemic, and I can say also because of the pandemic, because the idea was that we would help to contribute to a post-COVID-19 Europe, which will be more resilient, but at the same time more healthier, more green, more digital, and better prepared for the current and future challenges. There is a clear, distinct role between the European Commission and the agencies. The European Commission services, they are designing the strategies and the policies, they take legislative initiatives, while the executive agencies, they're implementing bodies. So we implement the policies designed by the European Commission. We also, therefore, we do this through project and program management. So we actually are responsible for the whole life cycle of the project, starting with the call for proposals up until the final payment. And we obviously provide feedback to the Commission, which they then can use for future policy making. We have a budget of about 20 million. Next slide, please. You can see that it's divided over 5 programs. I will not go into details. You're probably most familiar with the Horizon Europe program, which is the EU flagship for research and innovation, and in particular for its cluster 4, dealing with digital, industry and space, and which is also most relevant for our session. For 2024, we have a number of calls open, with a deadline on the 7th of January, calls that really relate to the energy-intensive process industries and clean steel. You can go for our website for more information. But now let me welcome Jürgen Tidje. Jürgen is representing the European Commission, and Jürgen will set the best scene, the policy scene, explaining to us how the EU works towards the decarbonization of the EU industry and what role research and innovation are playing in this process. Jürgen, please, the floor is yours.
Ladies and gentlemen, it's a pleasure to be here. It's a pleasure, before we start doing a deep dive into projects and what is happening on the ground, to set a bit the overall framework. And if we can come to the next slide. Thank you. The role of research innovation. Let me say a few words about it. We highlight here something which is hopefully well known, the European Green Deal. And we're all aware in Europe, this is not a Green Deal over the counter or somewhere on a smartphone. These are deep transformative policies. We have a Climate Act, which sets the scene, 2050. We need to be climate neutral. 2030, we have a target about 55% of reducing greenhouse gas emissions. This has huge repercussions on how do we move towards clean energy, how do we strive for a greener industry, what does this mean for our housing, what does this mean for the just transition, for the social aspects. So it's a huge transformative policy going on. Where is the role of industries and where is the role of research innovation in this regard? And if we can move to the next slide. Energy-intensive industries. 5% of gross domestic product in Europe and 70% share in terms of the greenhouse gas emissions. A clear case for de-risking investments to move to climate neutrality. And that's our goal. And this slide should just show to you that we are working not only in terms of research innovation, but we have a whole Green Deal industrial plan. So it's about industries at large. So we're looking at regulation, we're looking at standardization, we're looking at skills, we're looking at access to finance. And I'm happy here to quote also something from the IPCCI climate mitigation report, because I would like really to emphasize, we stand exactly also on what are the goals and what is analysis done by the IPCC. This is very important. So you see here, they are challenging to reduce the net zero CO2 emissions. Progressing towards them will be enabled by the adoption also of new production processes. And we are actually very much advanced as regards basic materials, primary metals, building metals and chemicals. Let us move on, please. Fit for 55. Research innovation is supporting all the various actions. And if you see all this, I will not go through this huge puzzle which you face. I will not embark on the carbon border adjustment mechanism, but I wanted just to explain to you, it's research innovation is not you think and you have a great idea. The transformative policies also for industry is driven by legislation, and you see here in particular the ETS directive and other elements. And research innovation has to be embedded on this. We are not funding the implementation of the new legislation. We're actually thinking, what are the technologies to be in place by 2030 and how we can go beyond. Let's move on. Okay, now we take a deep dive into European research programs. Horizon Europe. a budget of 95 billion euros. And I would like, you see all these nice circles here, I would like to go on the left side to the one called digital industry and space. This is the area where we provide work programs, where we offer funding for energy-intensive industries. And this is the space really to go also for energy-intensive industries to engage and to find, to apply for calls. If we can go to the next slide. Thank you. Working with industries does not mean working against industries or even without industries. So instruments which we're having are so-called partnerships. These are partnerships on pre-competitive research with the aim of transforming these industries to make them circular and to be climate neutral. How do we operate? We operate that industries suggest to us a roadmap which are the technologies to be put in place. We check, are these really technologies which will be there, which could be demonstrated by 2030, because energy-intensive industries have a very large investment cycle. To be profitable, to compete at global level, we need to be ready by 2030. You cannot say, oh, we have still 25 years to go. No, by 2030, these industries need to be ready. They need to be ready with having demonstrators in place, to have the technologies in place. And as Kathleen was already mentioning, this is a partnership looking at cross-cutting research topics, focusing on cement, steel. You have also the chemicals, which are, if you allow me, the biggest emitters of CO2 emissions. You have ceramics, you have also minerals and ores, non-ferrous metals, water, refineries, pulp and paper. So these are 10 sectors which are working together towards a roadmap, and we start implementing this roadmap. A partnership is something challenging. Why? We give money here in this regard. The European Clean Steel Partnership is something as a prominent flagship for us. The Clean Steel Partnership is looking also to have green steel. Do not use coke, use hydrogen for producing clean steel. Here we have also foreseen a budget, and if I can sum it up, the two partnerships we have actually in place, public funding 2.3 billion euros, but we expect also from these partnerships, when it comes to their share, that there are private investments from their side. So we expect at least equivalent amounts from their side to co-invest into research innovation, and in particular in the uptake of the innovations coming out of the Horizon Europe program. If we can go to the next slide. I'm looking a bit beyond, because research innovation normally stops at the technology readiness level number 7, but at the end, it's not only about funding research programs, it's about delivering on carbon neutrality. So what we're doing also in the research angle, we are looking into possibilities, options, and where do we stand? Are we actually able to scale up innovative technologies for climate neutrality in this area? You see here a link to a report published in June 2023. We identified 184 co-funded projects. I think it's an investment of more than 3 billion euros. And here we just showcase what exists, what should be scaled up. If we can go to the next slide. Very briefly, we have the so-called European Research Area. You have the single market, you have the European Research Area. This is a way of collaborating with member states and setting incentives for member states to do something similar under their national research programs. And one tool we are doing is industrial technology roadmaps, where we actually devise and shed some light on existing industrial technologies, allowing all member states actually to say where to invest under national research programs. And the particular focus is on closing the innovation divide. If we can go to the next slide. We are done, it looks like. So I was explaining to you, to put it in a nutshell, what is the role of research program, Horizon Europe? And I was explaining to you also the instrument about the European Research Area. Let me sum it up. We've put in place all instruments to make it happen by 2030, and we count also on the industries to do their part. Back to you, Kathleen.
Thank you so much, Jürgen. I think this was an excellent introduction into the policy initiatives, but also the policy targets, and then the role of research and innovation. We now can move to the more technological part of our session, and let us hear now how resource and energy efficiency gains can be obtained via retrofitting. And now I have the pleasure to give the floor to our second speaker, Angela Nunes, representing CECIL. Angela participated in the EU-funded project Retrofit, which is a 9.9 million EU-funded project. Angela, the floor is yours, please.
Thank you so much for this opportunity to join you today and talk about our Retrofit project. So next slide, please. So we all know that energy-intensive industry are responsible for high CO2 emissions that contribute to climate change, and improvements in energy and resource efficiency are key to this transition to a carbon-neutral industry. We have nowadays our plants. So existing industrial plants need to be transformed and to address this environmental challenge to remain competitive. And this means that we need to increase the resource of energy efficiency, decreasing CO2 emissions, decreasing the utilization of fossil fuels or resources, and reduce operational costs to keep productivity and competitiveness for the overall sectors. Please, next slide. So retrofit is a concept by retrofitting and simultaneous plus feedstock, and it means the implementation of a smart retrofitting framework in process industry towards its operation with variable bio-based and circular feedstock. It's very focused on 5 energy-intensive sectors as agrochemical, aluminium, cement, ceramic, and steel. This is our main consortium, and the total budget of the project is about 15 million euros, funding for UA about 10 million euros. So please, next slide. So the project main goals for hard-to-abate industry is very focused on improve energy efficiency, increase circularity and use of bio-based materials as alternative feedstock, for instance, secondary raw materials or alternative fuels, on the CO2 emissions reduction, process digitalization, and of course, the development of a retrofit methodology applied to the overall industry and that could be replicated for the overall industry. So please, the next slide. So focus on the cement sector. We all know that cement is very high energy intensive. So we need high amounts of thermal energy for clinker production. We need high temperatures. We also need high electrical power consumption for grinding and transportation. But the main impact, I would say, is CO2 emission. We have 2 main sources of CO2 emissions: the fossil fuel combustion, mainly petcoke or coal, and the limestone decarbonation. This is a chemical reaction that we cannot avoid. Thank you for changing. And this is an overview of the cement process, just for you to remember. And it all starts in the quarry with the exploitation of limestone and marl. And there we may use secondary raw materials. So these materials are grinded very fine and exposed to high temperatures. We are talking about 1,500 more or less degrees Celsius. So this to produce the clinker. Clinker is no more than an artificial rock designed by us, and after grinding becomes the cement that we all know. So for this, we need important amounts of fuels, basically petcoke, coal, and alternative fuels. I could say that the project is very focused on this pyrolysis process area. So mainly we want to abolish fossil fuels. We want to replace as much as possible fossil fuels for RDF, which is a waste material with specific heat, but is a poor specific heat. So we need a booster of energy to achieve these high temperatures. That's why we aim to go to green hydrogen as a main fuel. Please, next slide. So we have a demo site at Cecil Group in Portugal, in the center of Portugal, Maceira Lix plant. And we aim with this project to improve our environmental performance of this plant by replacing fossil fuels for alternative fuels, decreasing CO2 emission. And of course, we want to increase our knowledge of process and operations conditions and improve energy efficiency, basically. So next slide, please. So why we want to use alternative fuels? First of all, we want to abolish the fossils. So we need another source of energy. These materials are waste materials, and using them, we avoid landfilling and disposal or the dedicated incineration. But they have some characteristics that lead us to some challenges for us to use them in the cement kiln. And those characteristics are mainly the heterogeneity of the material, the variation of calorific value and moisture, the feedstock variability, and high chloride content. So these lead us to difficulties in terms of flame control, blockage, stoppage, and process instability. Sometimes it affects our clinker quality, and there is an overloss of energy efficiency and productivity that can reach about 15%. So next slide, please. So that's why we aim with the retrofitting with several actions that we implemented in this demo site to overcome these challenges. We try to implement, and we developed a digital twin of the kiln and a DSS system to support the operation and improve the decisions in operation. We also developed and designed and set up a new multi-fuel burner that allow us to increase the alternative fuels rates and the use of green hydrogen. And of course, we need information from the system. And that's why we implement a new sensor and control system, and we developed three main, I could say, new tools. So it's an image-based combustion diagnostic tool, focus on the flame, an alternative fuels properties determination in real time. So we need, with accuracy, the energy inputs and a real-time clinker optical characterization. It means that we have the output, the outcome from the process in terms of clinker quality. So next slide, please. The results. The results we achieve with all these implementations are very interesting. We have an increase of alternative fuels rate of about 13 to 34%, depending on the type of fuels that we are using. We had a reduction of on thermal energy of about 5%. As you know, when we increase the rate, normally we lose production and we lose efficiency. That was not the case here. So this leads us to a CO2 emissions reduction of about 7 to 11%. So very, very interesting results. And the last slide, please. So the overall impact on this demo site is basically process optimization and an advanced control and monitoring system that lead us to a clinker carbon footprint reduction from 7 to 11%, an energy consumption reduction by 5%, as said before, a productivity improvement. In fact, we get a much more stable process, so there are not so much stoppage and blockage. We can improve clinker quality because the standard deviation we will reduce, and we are ready, we can say, to a future hydrogen combustion use at industrial scale as long as we have this supply available. So thank you very much once again.
Thank you so much, Angela, for sharing your insights on the objectives of the retrofit project, and also for demonstrating to us how retrofitting can contribute to our goals. We now go to our third speaker, who's present with us here, Lisbeth Horkmans from the Flemish Institute for Technological Research. Lisbeth coordinates an EU-funded project, Carbon for Minerals, which receives 14.8 million funding. It's an ambitious project in the field of carbon capture and use. And Lisbeth, please, the floor is yours.
Thank you very much. Yes, indeed. So Thank you again for giving me this opportunity to present our projects. Unfortunately, okay, now it works. So first, before going into the project, I want to give you a bit of background also. As we have heard, so we have the different industries having developed roadmaps on how to get to the zero emissions by 2050. And as the previous speaker also said, for the cement industry, which is quite a large emitter, responsible for 6 to 8% of the global greenhouse gas emissions, they have a particular challenge, being that part of these emissions are really due to the process itself. So the transformation of limestone to clinker emits a large amount of CO2, which is just inherent in the process and which we cannot solve by being more energy efficient or going to renewable energy. So the cement industry has already a long history of looking for alternative materials, which we call supplementary cementitious materials, to replace the Portland clinker and thereby reduce the emissions. And so this is very important to do. They also look at capturing CO2 and store it to fill up the remaining gap, let's say. As you can see in the figure, a large part of the SEMs that are currently used are coal combustion fly ashes and blast furnace slag from the steel industry. Coal combustion will decrease in the future, and as you will see, also in the steel industry, there the roadmap is also towards more electrification, because we want to move away from the gas-fired blast furnaces towards more electricity using electric arc furnaces. But this means also that the production of the slags will change in the future, where now you have blast furnace slags that are a very common constituent of cement. In the future, this will decrease, and we'll be getting another type of slag, more EAF slags. Also, the steel industry relies on carbon capture and storage to fill up some of the gaps to really come to these zero emissions. Now, what we see is that this new type of slags, well, they're already there, but which will increase in the future, the EAF slags or the BOF slags that are currently there, their composition is more different from the Portland clinker than the blast furnace slag. So for these kind of slags, you will need to have a treatment to ensure that they are suitable to replace cement. And this is in two aspects. For one, some of the BAF slabs, they have a lot of free lime, calcium oxide, which when it comes into contact with water will form hydroxides, expand, and then you might get issues with pop-outs and so on in the concrete, which of course we want to avoid. And on the second part, of course, you need to have a sufficient reactivity to make sure it can replace the cement and fulfill the same properties. And carbonation is actually a good treatment to do both of these things. So we can react the calcium oxide with CO2, producing a limestone filler, which no longer has these dangers for expansion. And also reacting the calcium silicates that are present with CO2 leads to also this limestone, but also an amorphous silica phase that is a reactive material that can have pozzolanic properties, and it has been shown indeed that this can be sufficient to have the desired reactivity you need for a cement. Now, what we have seen before was, replacing part of the traditional cement we have with alternative materials. There is also technology to fully replace cement, so avoid cement altogether to make construction materials, which is mineral carbonation processes that we have developed already for a longer period of time, where you actually use the same reaction. So you also rely on the calcium minerals, the silicates, the hydroxides, to react with CO2 and form limestone. But in this case, these limestones that are formed actually act as a binder to cement particles together. So instead of having the hydraulic reactions you get with the cement, here you form carbonates that really increase the strength. And as you can see, we have already upscaled this process. There are actually building materials that will soon be on the market, which rely already on this process. However, so far, this has been done mostly using commercial CO2. So pure CO2 that has to be purchased to use. What do we want to do in the Carbon for Minerals project? We actually combine all these things that are happening, and we're trying, or we will, there capture CO2 and use this then directly to make our alternative cements and construction products, building materials. And we start from the flue gases of some of the energy-intensive industries, such as steel, cement, and bricks or ceramic industry, capture those with technologies and then use them further, or even we can go directly from the flue gases to the application with avoiding altogether this costly capture process in between. So indeed, as mentioned, so we started this project beginning of this year, and it will run for 4 years. And overall, we estimate that this has a significant potential to reduce then the CO2 emissions in the EU. What will we do in practice? We will indeed demonstrate the technologies at quite relevant scale already, aiming for TRL 7. For the CO2 capture, we actually have 2 technologies that we will demonstrate. One with the aim especially to go beyond the current state-of-the-art liquid amine absorption, which is quite a high cost and also high regeneration energy requirements, suffers a bit from corrosion and stability issues of the amines, and also these are typically very large installations which rely on the economy of scale to make it feasible. With our technologies, the first is a 3rd-generation biphasic solvent, which will have a lower cost and lower regeneration temperatures compared to the state-of-the-art, and also reduces the solvent degradation. And then secondly, we'll also be looking at solid absorption with structured sorbents that are also more suitable for small or medium volume installations, so you avoid a bit these very large investments, and also reducing the energy requirements there. In terms of the low-carbon cements and SCMs, we foresee to have 3 pilots there. One making a new type of carbonation clinker, and then 2 types of cement replacements that are made by carbonation. So as you can see, they have the potential to take up considerable amounts of CO2 instead of the alternative, which actually releases CO2 during its production. Also there, we're planning to have different pilot systems there that can really demonstrate what we're trying to do, and also increase trust for the uptake further on. And then I think finally also for the mineral carbonation products, as I mentioned before, the technology we have developed and upscaled so far really relies on commercial CO2. Here we want to go to using the flue gas of the industries themselves to make these products, and also expand the type of products that we can make, and also expand the raw materials that we can use for them. So we're looking here at bricks and pavers from steel slags, but also precast carbonation products which have a much greater flexibility in the type of product that you can make. And maybe a final thing to say is that we will also look into durability testing and validation of the standard test methods, because within the construction industry, it's very often more difficult to put in new products, new cements, because of all the requirements there. We want to invest sufficient time and effort to prove also that these materials meet all the requirements, so that we can facilitate the market uptake afterwards. And
Thank you very much.
that is my final slide.
Okay, sorry. Well, thank you very much, Lisbeth, for this presentation. Fascinating to learn how CO2 from flue gases can be turned into added value construction products, and therefore enhancing circularity and decreasing the CO2 emissions. What we've heard so far in terms of technological advancements and developments is interesting, very fascinating, I'm very impressed. So I suggest we continue our technological journey with Javier. So Javier, you will speak to us about the Power to High project, a 10.1 million project, which is developing alternative route for the production of hydrogen peroxide. Xavier, the floor is yours, please.
Thanks a lot for the introduction. To understand decarbonization in the chemical sector in the European Union, it's important to take into consideration how big is the sector, what it represents. So this chemical sector is strategic in the European Union economy. It is the second largest producer in the world in sales. is the fourth largest industry in the European Union and employs about 1.2 million of highly skilled workers directly and about 3.6 indirectly. And it further gives about 19 million employees about the different supply chains. So it's big, but it's also a third emitter of CO2 in the region. In order to tackle that, the European Green Deal was signed, and the target is to be climate neutral in 2050. And there is a roadmap developed for that. Among those different actions, there are electrification of processes, hydrogen with low carbon footprint, use biomass as alternative feedstock where possible, reduce the waste and reuse it if possible, use of carbon capture usage and storage, and to be more efficient in terms of process efficiency, in terms of the amount of resources that are used. So a very good example of that is the Power to Hype project, which aims towards the sustainable hydrogen peroxide production. So let's see what is hydrogen peroxide. Some of us are very familiar with it, some of us a bit less. It in fact is a widely used commodity chemical with a market evaluated at about 3.6 billion euros in 2020 and is forecasted to grow steadily in the years to come. It's listed among 100 most essential chemicals globally, and the capacity in Europe represents about 35% of the global production. That's about 1.2 million tons. This chemical is a powerful, environmental friendly oxidant, and it doesn't leave any residue. It just leaves water as a byproduct. Therefore, it is present in our life in multiple applications. It's present in bleaching of paper and textile. It's used as disinfectant. It's used in wastewater treatment. It's used for cleaning, etching, and chemical electronic components. It's used chemical synthesis, mining, batteries manufacturing, and batteries reuse. So, we today manufacture hydrogen peroxide. The current process is called autoxidation process. And in fact, it's a sequential hydrogenation and oxidation steps of working solution, which is composed of solvents and quinones. And this goes round and round in a loop. In the presence of noble metal materials, once we generate that hydrogen peroxide, this is extracted and then is distilled. Now, the two raw materials that are used, main raw materials, are hydrogen and oxygen. Where do we get the hydrogen? Is generally through steam methane reforming. And that technology generates a high amount of CO2. For the oxidation, generally use air, and this requires a high energy consumption in the compressors. It's the same for distillation. To increase the purity of the material, we use basically steam. That requires energy. And because we use organics in our loop, we need to purge those materials, and therefore there are also VOC emissions. So altogether, and despite the process is a very old process, 70 years old, is very well improved, it represents an environmental challenge. And for that reason, it was created Power to Hype. That Power to Hype project is a 4-year project that basically will enable a new electrochemical route for hydrogen peroxide. It will only use air and water as raw materials, and it's driven only by renewable electricity as the energy source. So the aim is really to replace the autoxidation process. The direct greenhouse emissions and the indirect greenhouse emissions are almost entirely eliminated with this process. The project started in 2023, and as you can see, basically there are 11 different partners in the consortium. There are from small and medium-sized companies to well-established companies, research institutes, universities, and everyone is expert in their own area, so that we can bring something of high added value to the consortium. Now, what is our approach? This project aims to really be on a sustainable route. And to make that sustainable route, we will make use of an electrolyzer. It's something called PER electrolysis, where we will generate hydrogen peroxide both at the anode and at the cathode. And we will use a custom-made electrolyzer for that. Once we generate the hydrogen peroxide, we pass it through a downstream purification process where we will rise the purity, and we will basically use different products for different market applications. With this project, we aim to really electrify and also decentralize the hydrogen peroxide. Today, hydrogen peroxide is made in big factories, but with this technology, we can really go and generate it on-site at a customer site. And we can use it also in different type of applications. Yep. If I go a little bit deeper into the project, and just to see what are the main steps that are identified and that we are working on, we can see it 6 clearly differentiated. First, we're working on the material development, so we really aim for advanced and commercially available materials and that are viable to make a large-scale production of hydrogen peroxide. So we are working on innovative catalysts which do not contain noble metals, gas diffusion layers. We are using also ion exchange membranes and BDD anodes. So once we develop all those components, we go to a next step, which is the cell design. In that cell design, we aim really to do a full scale up from 10 square centimeter cells to 200 square centimeters, which will be stacked and integrated pre and post reaction. Once we generate the hydrogen peroxide in that electrochemical cell, we will use the downstream processing, which will use low amount of energy to increase the concentration. And then we will take all that and we will pilot and demonstrate the viability of the technology, and we will basically certify that the component's lifetime will last enough time. One of the key focus of this project is really the energy load balancing. So we will evaluate the feasibility to use this technology with different energy sources. We will focus on the fluctuating renewable power supply. That means that can be a mix of photovoltaic, it can be used as solar panels, windmills, whatever is necessary. Lastly, there will be a digital twin, a life cycle assessment by experts to really determine the environmental, societal, and the really economical potential of the project. And to finalize, I think it is important to mention and really line out what are the impact versus the current well-established AO process. We aim really to achieve a better overall energy efficiency and save more than 25% of the energy that is used today. We will completely eliminate the direct CO2 emissions by the use of green electricity, definitely. We are using sustainable materials in it, leaving no subsequent generation of waste or side products, like, for example, avoiding the use of noble metals for catalyst. We will completely eliminate the VOC emissions because there are no organics used in this process. We will use also a low energy demanding concentration process afterwards so that we can elevate the concentration even up to 99%. We will adapt to really the intermittent availability of the renewable energy. And finally, we can decentralize the production. We can locate this technology in remote locations or even at customer site so that we can also eliminate the transportation, greenhouse gas emissions. And that's it. Thanks a lot.
Thank you very much, Javier, for your insights in the chemical sector and for explaining how electrochemical processes can contribute to reduce the CO2 emissions in the production of our chemicals. So we have now listened to our speakers. They shared with us fascinating insights on the EU policy framework, the EU targets. We heard about the role of R&I, and we heard about new technologies, all towards making climate neutrality a reality. So I would now like to look at the questions that we've received from the audience. So I'm looking into Slido, and I see already a first question for Angela Nunes. So Angela, the question is the following. What are the usual compositions and origin of the RDFs? Angela, please.
Okay, RDFs are basically waste materials with high specific heat properties. So mainly we are talking about, for instance, biomass waste, textile waste, organic waste coming from industry, tires, ships. So basically are these materials. Organic materials with specific heat. So it depending on the industry that we have nearby, but basically are these ones, paper.
Thank you very much, Angela. I think the next question is for Lisbeth. So in carbon for minerals, after capturing, how do you treat or purify the CO2 that will be used in the carbonization processes? Lisbeth, please.
Yes, so as I showed, there are actually two technologies that we will be further developing, but maybe important to mention is that these technologies themselves will already produce CO2 of a purity that is more than sufficient for our carbonation processes. So we actually do not need to refine it further, which is also, I think, quite a big benefit compared to the carbon storage, where you really need to have very, very high purity CO2. For the carbonation processes, actually, that's also the reason why in some cases we can also go directly from the flue gases. So after our amine process or the solid absorption process, we don't foresee any further purification of the CO2 because for our application that's not required.
Thank you, Lisbeth. And then I see there is also a question for Javier. So on power to hype, how will you integrate your new renewables as power supply in your process? Please.
That's rather simple. Basically, what we try to do is adapt the production of the plant to the energy available. So that means that sometimes overnight there is less availability of that energy, and we can decrease by 20% or 25% and really still making use of the process, so you don't need to stop. You can continue producing, and then when there is a large availability, be able to really cope with that. And that means it can be used for any type of renewable energy available.
Thank you, Javier. I see another question, maybe Jürgen, maybe you can take this question. What are or will be the hurdles to a large deployment of these technologies? Jürgen.
Well, this is a very big question. Let me try to give a few answers. Of course, the first question is access to finance. What we call in research innovation very often is a valley of death. So you're reaching a certain technology readiness level, and then you want to scale it up, and you know a normal investment fund or venture capital will tell you, I'm not going to invest in this, it's too risky. It takes, test it for 6-7 years, come back, and then I'm going to help you. So how do we bridge this valley of death? That will need, on the one hand, more public funding, for which you have the Innovation Fund. The Innovation Fund offers 60%, but 40% has to come from the outside world, which is very often not coming from private investors, but from public banks and member states. What we have recently seen is also a phenomenon that actually new funds are coming up who just focus on this valley of death. We call it GL 6 to 9. I've seen recently an example in the Netherlands. But that's a big challenge. The last one is that also in terms of access to finance, we do not believe that you have a kind of linear uptake of a given project. No, you have to live in a complete ecosystem to compare where can you actually combine. I think the second big challenge is really that we have a new approach on sharing of data. IPR is very important for a company, but we all have to think that in future it will be the value chains that will drive us, supply chains that will drive this. And the more we're actually holding back on sharing data, it's not going to help. That is, the data sharing is a big issue. Legislation, we hear quite a lot when it comes to waste legislation and circularity. I stop here because you can speak 1 hour about it. I'm pretty sure the projects as well, but it's a big issue. But as I said, public funding is available and also member states are ready to fund, and state aid rules actually have become a bit more flexible for scaling up.
Thank you very much, Jürgen. I believe we have now arrived at the end of our session. So, ladies and gentlemen, I'd like to warmly thank you for being with us today. And of course, I'd like to also thank our speakers. I think we can conclude our session with 3 takeaways. First of all, European industry is showing every day that it is ready to power the transition towards climate neutrality. Many technologies are already here to make it happen, but further innovation along the same pathways is needed, and this within the right policy framework. Jürgen mentioned them already. We talk about the EU Green Deal Industrial Plan, the Net Zero Industry Act, or the Process for Planet and Clean Steel partnerships. I can also say that HDEA, the Health and Digital European Agency, Executive Agency with the European Commission, is proud to play its part in this whole process, and we will continue to implement and to invest in research and innovation to enable a large scale-up uptake of the decarbonization technologies in the European Union. So, ladies and gentlemen, do not forget that we have open calls for 24. The deadline is the 7th of February for energy-intensive industries. I wish you all a good continuation of your activities at the COP28. And before you leave us, I would like to kindly ask you to check your screen at the end of this session for a short satisfaction survey on Slido about this event. Many thanks for being with us today, and goodbye.